We're doing the limiting reactant problem that we started yesterday. Darn it, forgot. Now, what you should be able to do is, if you had finished this problem with shortcut, you could actually check your answer, can't you? All right, so here we go. Help me out, Layla. Layla, tell me what to write down here. What do I do first? All right, wait a minute. That's really good. Fast, fast, fast. Now go ahead, next.
And then you would put moles of N2 on the bottom.
Yes.
And then grams of N2.
Yes.
And then 28 grams go on the top.
28 grams is the same as what?
Or 1 mole.
Yes. So right now, I would go ahead and put that in the calculator, and I should be able to write that number. What did you get for this, Layla?
10.6 moles.
10.6? Oh, moles. No, I mean grams, you mean, don't you?
Yes.
10.6 grams?
Yeah.
Did everybody get 10.6? Okay. Now, instead of me starting a whole nother problem, I can actually start right here, and I could convert that to liters, because it is a gas, isn't it? And let's think about this again. 1 mole of N2 is 6.02 times 10 to the 23rd molecules of N2 equals what? Layla said 28 grams of N2. And if you're a gas, what can you say? 22.4 liters of N2. All right, go ahead, Layla. Can you finish out the problem for me? What label has to go away?
Grams.
Yes?
And then liters of N2.
Okay, so tell me some numbers.
22.4 goes to liters. And then 28.
That's right, 28 grams, okay? All right, and what do you have up here for liters?
8.5.
How much is it?
8.5.
Okay. I had somebody else do it, another class, they got 8.44. Is anybody getting something close to 8.5? You're getting 8.44? Okay. Now, let's say on the test, I really do want you to use shortcut, right? What would be the shortcut to go from here to here? What's the shortcut? You want to come up out of the mole world, what do? Multiply by the molar mass of N2. So let's try it. Try that right now. Put your calculator, say 0.38, multiply by 28. Let's see if you get that. And if you're not getting the same answer with factor labels, you do shortcut. We got to figure out what's wrong. Now, what's the shortcut for liters? I'll tell you the shortest shortcut is moles times 22.4. Let's try that. Put moles times 22.4 and see if you get that number there. You know, some of you, by now, you're feeling so comfortable with the factor label. If you look down here, the shortcut said take moles times molar mass to get up here. Look what happened when you show your work. What are you actually doing there? You are multiplying by the molar mass. See that? Okay, is everybody okay on that? And then the water, let's do the water. Let's have Zach help me with that one. What I'm going to write down, Zach? I'll let you go ahead. If you want grams of water, I'll let you go ahead and start with that number right there. What am I starting with? Label. What? What's my label? What's my given? Of? And what I would do is, since they want me to find this guy, right? As long as I didn't make a mistake, I can go ahead and start with this. So 1.1 for what? Moles of water. Okay, now tell me what to do next, Zach. What has to go down here? Of what? Of water? So you're going to change moles of water to what? What numbers I put here? 18. Say it again.
18.
Okay, so let's go ahead and put that in there. And what's your final answer?
20.4.
20 point what?
52.
Is everybody else getting something like that? Okay, good. Everybody okay on that? Now, what I'd like to do, go ahead, if you don't mind, let's just do a quick shortcut. Do a quick shortcut and change this into grams too, okay, would you? You know, everybody knows the shortcut, right? Multiply by molar mass. And go ahead and give me that number there. And let's see, May, what do you have for this number right there? So it's got, you take the shortcuts, moles, you multiply by the molar mass of copper. Okay, what do you got? Do you have a calculator?
No,
Uh-oh. All right. I don't think this works anymore. My graphing calculator has never been returned. Let me just see if this one works. Here, you want to use this for right now? It's really an old-fashioned calculator. But at least it works. So now, what I'd like to do is, does anybody happen to have this number here already? Madison, do you already have that? 72.
72.4.
Okay, is everybody getting something like that? Now, what's interesting, what's very interesting about these problems, I want you to add these up real quickly and tell me what you get. Add up the reactants. Add up the reactants. Okay, do that now. So I'm going to put a little thing here. What is the total mass? The total mass of the reactants right now. What's the total mass of the reactants? And I'll bet it's 108.5. Is it 108.5 grams? And then what is the total mass of the products? Okay, so that one I can't do in my head very well. 92, 92.93, 92.93, 92.93, 102.93, 102, 103.5. What is it? 103. Anybody have it? 103.5. Now, you know, if this was in a couple thousand grams, I could say being off by 5, that would be okay. But I don't know about this. Something's not right here. Something's not right here. And I want to show you why it's not right, okay? Is everybody ready to take the next? I'm going to show you this. This is the stuff I've never taught yet, okay? In a chemistry problem that's limiting reactant, we have two reactants, the peanut butter and the bread. If the bread happens to be the limiting reactant, they have a name for the other reactant. The name for the reactant that you're not going to run out of first is the one that's in excess. If it says which reactant is in excess, that means which one are you going to have left over. So if this is the limiting reactant, then the one that's in excess is NH3. Yes?
How do you know what is the
Okay, how to know which one? Okay, these are the two reactants, right? And this little asterisk said that's how much peanut butter you brought. This says that's how much bread you brought. And so what I did here, I went like this. This is how I answered this question. I have that much peanut butter. If you don't like me saying anything peanut butter, I'll be very chemical with you. I have this much ammonia. I would need this much copper 2 oxide to completely react with me. Did you bring me that much? And the asterisk says, no, I didn't. That's what the asterisk's about. The asterisk is how much you actually have, isn't it? It's not how much you like to have, it's how much you have. And so I need this much. I'm sorry, I didn't bring that much. Then you are going to limit how many sandwiches you're going to make. And so, see the category? You are the limiting reactant. That number is how I got all the other numbers. Now, if you're the one that's a limiting reactant, what do you call this guy? That's the reactant that's in excess. Let's go down here. How many moles of what? Excess reactant will there be left and not reacted? Does anybody want to take a chance and tell me how to do this? What? Somebody said it. What? Yes. Look, excellent. Look, watch here. Ready? That asterisk said, I brought how much peanut butter? I brought that much. How much are you going to end up using? This says here, I'm only going to use up how much of the peanut butter? 0.76. But I brought way more than that. Well, too bad. I won't be using it. Oh, I could do that. These are moles, right? All right, what do you get? What's that number? I think I have it written down. Is it 0.3? What is it? 0.3? Is that it? Okay, so how much is left over? 0.3 moles of ammonia are left over. Is that right? So how much is in excess? 0.3 moles. Okay, so that's the first part of the answer. What's the next part of the answer? How many grams would that be? All right, what do you think? How do that? How do I change this? I want to know how many grams. What would I do here? What would I put down here?
Multiply 0.3 by 1 mass.
Yeah, that's a shortcut. Show me how to do it with factor label. What label has to go away?
Moles.
Of ammonia. Okay, what are you going to put up here?
Grams.
Yes. Yes. What do you know about these two? They have to be equal.
What's the molar mass?
What's the molar mass of ammonia? Okay. So what do you know about ammonia? How many moles? 1 mole ammonia equals how many grams? Remember, if we were doing, remember the equivalence? 1 mole ammonia equals how many grams? See, the only danger with only knowing the shortcut, if you don't know how the shortcut works, that's a problem. So we'll just give it to me, and I think you come out with, does anybody have this already? What's 0.3 times 17? 5.1? 5.1? Now I want to show you something. It's a little magical. Okay, see these numbers here? You know why we weren't closer? See, if you don't have a limiting reactant, they get really close. The grams of reactants equals the grams of products. You get that? Why is this one off? And how much is off by? Can everybody do a little quick subtraction problem here? You know how much it's off by? 5 grams. Uh-oh. That's why you're off. Because it's true, a certain number of grams of that did react with a certain number of grams of that, but then there were 5 grams that never reacted at all, and they were left over, and that's why you're off by 5. If that's too advanced for you, I'm not going to ask you that again, but if you do this on a limiting reactant problem, they don't match because there's always some that never got to react. Yes?
Can you just subtract the 2 masses?
Say it again?
Can you just subtract the 2 masses? Like, the react,
For which though?
like to find the leftover.
See, here's the problem. You might have brought this much peanut butter, but you know what? I didn't use it all. I did use all that. You know how I know that? That was the limiting reactant, wasn't it? The limiting reactant runs out of first. You used all of that. You used all the bread up. But did I use all that peanut butter? No, I didn't. Can you do me this is a high level. Let me do one more high level question, okay? Take that number there and tell me how many grams that is. 0.76 moles of ammonia. How many grams is that? Just a little higher level, okay? 0.76. What do you got?
12.9.
Wait, one more time.
I got 12.92.
Okay. Now, do me a favor. Take this number minus that. You know what? I brought 18.1 grams of peanut butter, but I didn't use it. I only used about 13. So what is it, 5 or something like that? See, oh, look at that. Oh, this is like scary. And so one thing I want to show you is that I might have brought that much peanut butter, but this number here tells me you really only use about 13 grams of it. That means 5 is just sitting there doing nothing. And that's why your numbers are off down here by 5. They won't be off. Like the thing you did yesterday, the one you did yesterday, a not limiting reactant, they're not going to be off. They'll be off by a little bit. But this is always going to be off because you have stuff left over. Now I want to practice one other thing that we did last week. Earlier this week. It's called percent yield. Do you remember percent yield? And you're going to do a lab. And the lab you're going to do is a limiting reactant lab. That's why I had to teach this to you. Get it? You're going to use real chemicals. You're going to do all the calculations just like this. And what I want you to do is I eventually want to figure out what is your percent yield. Now, I know what you're thinking. Well, I'm going to get 100%. And you know who I am. I'm perfect. And you think when you do the lab, you're going to get 100%. But you'll see as you do the lab, oh, well, that's not good. That's going to make me not get 100%. And even in the real world of industry, they would like to have 100% yield, but you can't. It's difficult because there's always stuff left in the container, or there's stuff that you didn't have the calculations quite right, or something happened. See that? So let's do a percent yield. All right, I'm going to make up a problem, and here it is right here. When a first-year chemistry student actually did the experiment, he produced 8.5 grams of nitrogen. What is the percent yield? Okay, do you remember how to do this? What is the equation for percent yield? And percent yield is what percent correctness, how well did you do compared to the perfect world, right? And what is the equation again? It's an easy one. Anybody raise your hand if you remember. We did this about 2 days ago. Okay, so what it is actual yield. The actual yield over the theoretical yield times 100. Okay. Over theoretical yield times 100. And I mentioned this before. You're going to get a decimal number like 0.50, and times 100 simply moves a decimal over. Does your math teacher teach that to you? Does your math teacher say 0.86 is the same as 86%? Is that what they tell you? Does they just simply tell you to move the decimal over 2 places? Is that what they do? Well, guess what? 100 multiplying by 100, what's that do? It moves the decimal place over 2. So don't let that scare you. That just means move that decimal over. All right, so what do you got here? What was the actual yield? Somebody who actually did the experiment, what did they get? Look up here. All right, 8.5 grams. But where's the theoretical yield? And guess what? Everything you did up here, nobody got any equipment out, did they? Did you get any chemicals out? Everything up here is theoretical. See that? In the perfect world, how much N2 would you gotten? What do you got? In the perfect world, they would have gotten at what number? 10.6. Let's do it. Find their percent yield in. Ready? When they actually did the experiment, they got 8.5, but in the perfect world, they should have gotten 10.6, shouldn't they? So put that in a calculator, and what do you think? Are they doing pretty well or not? Dan, do you already have it done? What do you have?
79.9.
That's not bad. 80% yield, that's not bad. There are some companies out there that may only get like 70% yield or 60% yield, and they're always trying to get better and better, and they hire chemical engineers to come in and say, look at how we make our product. Please help us to be a higher percent yield so we can make more money or hire more people or not get outcompeted by another company. And that's why they pay chemical engineers so much money. They not only know the chemistry, They also know about how chemical factories are made. And they have to figure out all that. It's physics, it's chemistry. That's why they pay them a lot of money, because they try to problem solve at a big level, Wait a minute, did everybody get around close to 80%? All right, what do you think? Now, believe it or not, that's everything that's in this chapter. That's everything. We just need to practice. You get it? We need to practice. All right. I want to give you a. I think I photocopied it. This right here is a great practice test. Now, the real test, though, will mostly be multiple choice. So that means you want to use shortcut all the time. You don't have to show your work, right? But this is a good one because it does make you show your work, and there's other times you're going to use shortcut. It even has on the back some vocabulary words. Well, the first part of the test you're going to see is vocabulary words. And so I want you to, I'm going to have you sit in groups, okay? And I'll give everybody one of these, and this will be another homework assignment for you. This will be what you turn in on the day of the test. You'll give this to me on the day of the test as another homework grade, and then we'll. And I do want to move the test to Wednesday, okay? So you have today and tomorrow to work on this, and then maybe we can Monday. But I looked at the test count. I believe you have. Can you help me out with that? I believe you have a lot of things going on Monday, don't you? So I just can't. That'd be too much. That'd be too much for me to do. Now I am going to walk around the room. I'm going to walk around the room, and I want to help you. Okay? I want to help you. You gotta force each other. If you're in a group, you force each other to do it the right way. All right, thank you very much for handling that.
Madison, I'm so uncomfortable.
All right, I'm gonna walk around the room, and like I said, I just want to see you do the thing the right way. You have one?
Yes, sir.
Put your desk a little closer, so I can see right on that. All right, so I'm gonna sit here just for a little bit. I want to hear what you say. So, how do we start this? Magnesium.
So we get a chair on the table.
You know you're not gonna do any quick geometry unless you have a balanced equation. You know that, don't you? So you better balance that equation first. Hey, if you don't balance the equation, you better not be doing any quick geometry. You better balance that equation first.
It's tool. And then you put the equivalent system.
Yes, things that are equal to each other. 24.3. That's grams, isn't it? That's grams.
Yes, sir.
Go 2. 16 plus 2 times 2. Grams.
And then
There's a hard, magnesium oxide. There's 24.3 plus 16. That'd be 40.3. See, we're getting good, aren't we? You have a balanced equation or not?
Yes.
Okay, so now, we'll go ahead and start with shortcut. Start with shortcut, and then we'll do the calculator, okay?
Yes, sir.
Oh, all right. Thank you. Okay, I'm gonna try to
You just haven't done my Spanish.
Yeah.
No, it's either. What if
really 0.05 or is it 0.0511 or?
But zero doesn't count as a zero.
Not until it's half. If you go left to right, you don't start counting until you get to one. There's your first sig fig right there.
The five is the first sig fig. Okay, and if it's behind, does it count as a sig fig?
If it's after another sig fig, it does count.
Okay.
So,
I forgot about that.
what is that number? Is it really point, yeah, thank you. 05140, yeah. Hey, don't go below 3 significant figures, alright? Don't go below 3 significant figures, like on this right here, what do you guys get in on that? There's 1, 2, that's 2 sig figs, that doesn't count. What's your number after, 0.051 or 4, that's 4? First box should be 0.0514. Okay? That's only 2 sig figs. You don't count. You put 4 in, yes. There you go. Don't go below 3 sig figs or your numbers start getting, too far off. Alright, so you have a circuit? So this one, should be 0.0514. And that's gonna probably change that one. I'll take that down. So you change that to 0.514, and you're gonna cut the time in half.
So the input light is on me and on you.
You get that 3 sig fig. Yeah, there you go.
Kyle?
Do you have a match here? Make your number just a little bit easier to read. So now you go back to the factor label and you see what get that. You start probably doing 1 sig figs, all your numbers get off. Oh, you said it did. Wow. This is 0.025.
That's good.
Pretty good.
I've never seen them play. I've only seen them a little bit. No one really takes the golf team seriously. It's not I guess some people do, but a lot of people like just do it for fun. Which is different from hobby. That is true.
Free golf at a nice golf course. Somebody takes
So that pretty much means
$100
you
for a cart and the green fees and all that.
Girl.
Yeah, I'm gonna start playing golf.
All right.
I'm trying to get golf. I'm almost ready.
All right, is your okay here?
Yeah.
Right, that table is very well set. Oh, what happened to shortcut? What happened out here? That should be done. Let me see your shortcut.
There was 9 inches. There's 9.
I always get multiply, so I don't have to worry about it. So, 2,
Okay, if you're just.
it's smaller, multiply by what? That's it. And that is the same as dividing by 2, but I don't want to mix people up, so I just say.
Honestly, I don't want to get it. It's so fun.
And that's 3 sig figs, all right? Now, if you're gonna do a matchy-matchy, then they come up, how do you come up out of the water? Okay, it's a line, right? And you never look at color, it's just when you go up or down. Ever been more matchy yet, right? You did.
Oh.
You did shortcut, but
do know, but when the other night we talked about it,
Or just do it the way, just do it the way you normally do it.
well,
Just the way you normally do it. I am proud of you. This is good.
It's time to. Restrain the slaves. I did not know. Really just country to save a few slaves, you know, just imagine. That's not what I would think.
Yeah, definitely. You have to have a certain amount of speed.
Good.
You got to like this.
Continues a dream. Definitely not related to.
All right, hey, thank you very much. That was a great day. I'm hoping you're gonna keep doing what you've been doing. All right?
Yeah,